Article 220.4 of the 1999 National Electrical Code permits neutral conductors of circuits having more than one branch circuit to be blue, light blue, or white in color. If the branch circuit has a rating of 15 amps or less, you may also use a light gray colored neutral. The code section has been updated since 1999, but the section is still there. The National Electrical Code, or NEC, is a widely adopted standard for the safe installation of electrical wiring and equipment in the United States. It is updated every 3 years, so it's crucial to consult the most current edition for the latest regulations. The NEC addresses various aspects of electrical systems, including wiring methods, overcurrent protection, grounding, and conductor identification. Neutral conductors play a vital role in electrical circuits by providing a return path for current to the source. They are typically identified by their white or gray color, as specified by the NEC. However, there are specific instances where other colors, such as blue or light blue, are permitted for neutral conductors. The use of blue or light blue neutral conductors is primarily allowed in circuits with multiple branch circuits sharing a common neutral. This configuration is commonly found in multi-wire branch circuits, which consist of 2 or more ungrounded conductors sharing a single neutral conductor. The NEC permits the use of blue or light blue neutral conductors in these circuits to provide a clear visual distinction from the standard white or gray neutral. This color coding helps prevent confusion and ensures proper identification of the neutral conductor, especially in complex wiring systems. It is essential to note that the use of blue or light blue neutral conductors is not a universal practice and is only permitted under specific conditions outlined in the NEC. Generally, the standard white or gray color should be used for neutral conductors in most applications. However, when dealing with multi-wire branch circuits or other situations where multiple circuits share a common neutral, the use of blue or light blue can be a valuable tool for identification and safety. The 15 amp or less rating for light gray neutral conductors is another specific provision in the NEC related to conductor identification. This allowance is typically applicable in residential or light commercial settings where branch circuits are rated for 15 amps or less. The use of light gray neutral conductors in these circuits provides a similar benefit to the blue or light blue conductors in multi-wire circuits, allowing for easy identification and differentiation from other conductors. It is important to remember that the NEC is a comprehensive document with numerous articles and sections that govern electrical installations. When working with electrical systems, it is always recommended to consult the latest edition of the NEC and seek guidance from qualified electrical professionals to ensure compliance with all applicable codes and standards. Firstly, understand the fundamental role of a neutral conductor in an alternating current, or AC, electrical system. The neutral conductor provides a return path for the current, completing the circuit back to the source. Typically, in North America, the neutral conductor is identified by a white or gray insulation. Secondly, recognize that the National Electrical Code, or NEC, provides guidelines for the identification of conductors, including neutral conductors, to ensure safety and proper functionality of electrical systems. The NEC is updated regularly, typically every 3 years, to incorporate new technologies, address safety concerns, and clarify existing requirements. Thirdly, the specific section of the NEC that addresses the color coding of conductors is found in Article 200, titled Use and Identification of Grounded Conductors. This article outlines the requirements for identifying grounded conductors, which include neutral conductors. While the general rule is that the neutral conductor must be white or gray, there are exceptions for certain applications. Fourthly, the allowance for using blue or light blue neutral conductors, as mentioned in the context of the question, typically applies to specific situations such as multi-wire branch circuits. A multi-wire branch circuit consists of 2 or more ungrounded conductors that share a common neutral conductor. This configuration is commonly used to provide multiple circuits from a single supply, reducing the number of conductors required. Fifthly, in a multi-wire branch circuit, the NEC permits the use of different colored conductors for the ungrounded or hot conductors to distinguish between the different circuits. In some cases, the neutral conductor may also be required to be a different color than white or gray to further differentiate it from the other conductors. Sixthly, the use of blue or light blue for the neutral conductor in a multi-wire branch circuit is not a mandatory requirement, but rather a permitted option. The decision to use a different color for the neutral conductor depends on the specific circumstances and the preferences of the electrical designer or installer. However, if a color other than white or gray is used for the neutral conductor, it must be permanently re-identified at each termination and access point. Seventhly, the allowance for using light gray for the neutral conductor in a 15 amp or less branch circuit is another specific provision in the NEC. This provision is intended to provide additional flexibility in conductor identification, particularly in residential or light commercial applications. Eighthly, the use of light gray for the neutral conductor in a 15 amp or less branch circuit is not a mandatory requirement, but rather a permitted option. As with the use of blue or light blue, the decision to use light gray depends on the specific circumstances and the preferences of the electrical designer or installer. Ninthly, it's crucial to understand that the NEC is a complex document, and it is essential to consult the latest edition and any applicable local codes and regulations before undertaking any electrical work. The NEC provides detailed requirements for conductor identification, wiring methods, overcurrent protection, grounding, and other aspects of electrical systems. Tenthly, always prioritize safety when working with electricity. Ensure that you are qualified and trained to perform the work, and use appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses. Disconnect power to the circuit before working on it, and verify that the circuit is energized using a reliable voltage tester. 11thly, if you have any questions or doubts about the NEC requirements or the proper way to perform electrical work, consult with a qualified electrical inspector or engineer. They can provide guidance and ensure that your work complies with all applicable codes and standards. Furthermore, consider the impact of using different colored neutral conductors on future troubleshooting and maintenance. While the NEC permits the use of blue, light blue, or light gray neutral conductors in specific situations, it is important to ensure that the wiring system is properly documented and labeled to avoid confusion. Clear labeling of the circuit breakers and wiring terminations can help electricians and maintenance personnel quickly identify the different circuits and conductors, reducing the risk of errors or accidents. Additionally, consider the availability and cost of different colored conductors. While white and gray conductors are readily available and typically the most cost-effective option, blue, light blue, and light gray conductors may be less common and more expensive. Therefore, it is important to weigh the benefits of using different colored conductors against the potential cost and availability considerations. In some cases, it may be more practical and cost-effective to use white or gray conductors and rely on other methods of identification, such as labeling or tagging. Moreover, be aware of any local amendments or interpretations of the NEC that may affect the use of different colored neutral conductors. Some jurisdictions may have stricter requirements or specific interpretations of the NEC provisions related to conductor identification. It is important to consult with local electrical inspectors or authorities to ensure compliance with all applicable codes and regulations. In addition to the NEC, other industry standards and best practices may provide guidance on conductor identification and wiring methods. For example, the National Electrical Manufacturers Association, or NEMA, publishes various standards related to electrical equipment and wiring which can be helpful in ensuring safe and reliable electrical installations. Remember that the NEC is a minimum standard, and it is always permissible to exceed the requirements of the code to enhance safety or performance. For example, you may choose to use heavier gauge conductors, install additional overcurrent protection, or provide redundant grounding to improve the reliability and safety of the electrical system. The ultimate goal is to create a safe and functional electrical system that meets the needs of the users and complies with all applicable codes and standards. The NEC is a valuable resource for achieving this goal, but it is important to use it in conjunction with sound engineering judgment and best practices. In summary, the NEC permits the use of blue, light blue, or light gray neutral conductors in specific situations, such as multi-wire branch circuits or 15 amp or less branch circuits. However, It is important to understand the specific requirements and limitations outlined in the NEC and to consult with qualified electrical professionals to ensure compliance with all applicable codes and standards. Always prioritize safety when working with electricity and use appropriate personal protective equipment. By following these guidelines, you can ensure the safe and reliable operation of electrical systems. When working with electrical systems, it's important to understand the role of different types of conductors. Firstly, grounded conductors, often referred to as neutral conductors, provide a return path for current back to the source. They are typically identified by a white or grey insulation. Secondly, ungrounded conductors, also known as hot conductors, carry the electrical current from the source to the load. They are typically identified by black, red, or blue insulation, depending on the voltage and phase of the circuit. Thirdly, grounding conductors provide a path for fault current to flow back to the source in the event of a short circuit or ground fault. They are typically identified by green or bare copper insulation. The NEC specifies the requirements for grounding and bonding electrical systems to ensure safety and prevent electrical shock hazards. Grounding involves connecting the electrical system to the earth, providing a low impedance path for fault current to flow back to the source. Bonding involves connecting all metal parts of the electrical system together to create a common ground, minimizing the potential for voltage differences between different parts of the system. The NEC also provides requirements for overcurrent protection, which is designed to protect electrical circuits from excessive current that could cause overheating or damage. Overcurrent protection devices such as circuit breakers and fuses are designed to trip or blow when the current exceeds a safe level, interrupting the flow of electricity and preventing damage to the wiring and equipment. When working with electrical systems, it's important to select the appropriate size and type of conductors for the application. The NEC provides tables and guidelines for determining the ampacity, or current carrying capacity, of different types of conductors based on their size, insulation type, and installation conditions. The ampacity of a conductor is the maximum amount of current that it can safely carry without overheating. It's important to select conductors with an ampacity that is sufficient to handle the expected load current, plus any additional current for future expansion or contingencies. In addition to ampacity, it's also important to consider the voltage drop in the conductors. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause equipment to operate inefficiently or malfunction, so it's important to select conductors with a size that minimizes voltage drop. The NEC provides guidelines for calculating voltage drop and recommends limiting voltage drop to a certain percentage of the supply voltage. When installing electrical wiring, it's important to follow the NEC requirements for wiring methods. The NEC specifies the types of wiring methods that are permitted for different applications, such as conduit, cable, and racewire. Conduit is a rigid or flexible tube that is used to protect and route electrical wiring. Cable is a factory assembly of two or more conductors that are enclosed in a protective sheath. Raceway is a channel or trough that is used to support and protect electrical wiring. The NEC also provides requirements for the installation of electrical boxes and enclosures. Electrical boxes are used to enclose wiring connections such as splices and terminations. Enclosures are used to house electrical equipment such as circuit breakers, transformers, and control panels. It's important to select electrical boxes and enclosures that are appropriate for the environment and the type of equipment being installed. For example, outdoor electrical boxes and enclosures must be weatherproof to protect the wiring and equipment from moisture and corrosion. When making wiring connections, it's important to use the proper techniques and connectors. Wiring connections must be made securely and reliably to ensure good electrical contact and prevent overheating. The NEC specifies the types of connectors that are permitted for different types of wiring, such as wire nuts, crimp connectors, and terminal blocks. Wire nuts are used to connect two or more conductors together by twisting them together and then covering them with an insulated cap. Crimp connectors are used to connect conductors together by compressing them with a special tool. Terminal blocks are used to connect conductors to electrical equipment such as circuit breakers and control panels. When working with electrical equipment, it's important to follow the manufacturer's instructions and safety precautions. Electrical equipment must be installed and operated in accordance with the manufacturer's instructions to ensure safe and reliable operation. It's also important to wear appropriate personal protective equipment, or PPE, such as insulated gloves and safety glasses, when working with electrical equipment. Finally, it's important to have your electrical work inspected by a qualified electrical inspector to ensure that it complies with the NEC and local codes. Electrical inspections are designed to identify any potential safety hazards or code violations and to ensure that the electrical system is installed correctly and safely. The electrical inspector will typically review the wiring plans, inspect the wiring installation, and test the electrical system to ensure that it meets all applicable requirements. By following these guidelines, you can ensure the safe and reliable operation of electrical systems. Electrical work can be dangerous, so it's important to take all necessary precautions and to consult with qualified electrical professionals if you have any questions or concerns.